The objective of this lesson is to be able to identify when two expressions are equivalent by substituting a value into them. An expression is a variable or combination of variables, numbers, and symbols that represent a mathematical relationship. For expressions to be equivalent, they must yield the same result regardless of the number used for the variable. We can use substitution to prove if the expressions are equivalent. Let's look at the following two expressions to determine if they are equivalent. We can substitute any number for the variable x to determine if the two expressions are equivalent. Let's use the number 5. We will substitute in a 5 for the variable x. Knowing the order of operations in the first expression, we know that multiplication is performed before the addition. So 3 times 5 equals 15. 15 plus 12 equals 27. Now we will substitute a 5 in for the variable x in the second expression. 3 times 5 equals 15. 7 plus 5 equals 12. And 12 plus 15 equals 27. The two expressions are equivalent because when we substituted a 5 for the variable x, both expressions equaled 27. Let's look at another set of expressions to determine if they are equivalent. We can use any number for the variable y to determine if the two expressions are equivalent. Let's use the number 2. We will substitute in a 2 for the variable y. In the first expression, remember we always do multiplication or division first. So 6 times 2 equals 12, and 2 times 2 equals 4. 12 minus 4 equals 8. Now we will substitute a 2 in for the variable y in the second expression, again doing the multiplication first. 5 times 2 equals 10, and 1 times 2 equals 2. 10 minus 2 equals 8. The two expressions are equivalent because when we substituted 2 for the variable y, both expressions equaled 8. Let's look at another set of expressions to determine if they are equivalent. We can use any number for the variable r to determine if the two expressions are equivalent. Let's use the number 3. We will substitute in a 3 for the variable r. In the first expression, 2 times 3 equals 6, and 6 plus 5 equals 11. Now we will substitute a 3 in for the variable r in the second expression. 2 times 3 equals 6, and 6 plus 3 equals 9. Because the two expressions do not give the same result when substituting in a 3 for the variable r, they are not equivalent. For our last problem, let's use algebra tiles to model the two expressions. The two expressions we will determine equivalent are 6 parentheses x plus 2, close parentheses, and 12 plus 6x. We will use the x tile to represent x and the 1 tile to represent each number 1. 6 parentheses x plus 2, close parentheses, means that we actually have 6 groups of x and 6 groups of 2. Notice that 6 groups of 1x is the same as 6x. 6 groups of 2 is the same as 1 12 times. Some students may need to see the conceptual models to understand how the expressions are equivalent. Once students have a conceptual understanding, they will be able to substitute any number for x and be able to solve the expression. The objective for this lesson was to identify when two expressions are equivalent. We met this objective by substituting a value in for the variable and evaluating each expression to determine if the expressions gave the same result. And we also used algebra tiles as a model to show the equivalent expressions.